Number 12 then from paper 2 of the 2025 Advanced Higher Maths, 9 marks, getting into the big guns now. Solve this second order differential equation. You've also got some initial conditions here, so you can put that in and get a particular solution, not the general solution. Well, it's just a case of go through the routine. So the routine is, first of all, get the complementary function. What solves the homogeneous equation? That is the equation equal to 0. Homogeneous because they've only got terms in y. Well, for that you make up the little auxiliary equation, because there's only one type of term that would work for that, where you've got something and its derivatives, and they're all ending up more or less the same, so they knock each other out to give 0, and that's e to the something, and its partners in crime, sine and cosine. Well, the auxiliary equation will be m squared minus 8m plus 15 equals 0. So that's m, and that'll be 3 and 5, and that'll be minus minus, so there you are. M equals 3, m equals 5. Those would be the coefficients of x and those exponential terms you would put in. So that means you get your complementary function. YC would be, well, whichever way around you want it. Maybe I'll put the higher power first. A lots of e to the 5x and b lots of e to the 3x. Right, next, what's the particular integral? In other words, what kind of function would, if you kept it and then added on its various higher derivatives, produce something like this? Well, it'd have to be something like that, because there's going to be any higher power than that. So I'm just going to go for my particular integral will be, I'll have, we've used a already, will be some law of x squared minus some law of x, plus a constant. And to see if that works, I just feed it into that. So I want the first derivative, which will be 2cx plus d, and I'll just use that for the abbreviation, and that's just 2c. Then feeding those three into those three parts and equating it to this term by term will give you the values of c, d and e if they work. But I'm not going to feed them all in and put a big line and then gather them up. I'm just going to gather them in one go by taking a note how many I need of each of these. Of the second derivative, I just want 1. Of the first derivative, I want minus 8. And of the term itself, I want 15. So now we can just gather up each of the parts. So that means for x squared, I've got 15 of them. So I've got 15c x squareds. Now, there are two terms that give me x. So I've got a 15d minus 8 times it, minus 16c, lots of x, and then there are 3, I don't actually need the bracket, but anyway. I've got 15e, this is for the constant, minus 8d and plus 2c, and that lot is should be the same as 15x squared minus 31x plus 40. Now you can equate the parts. X squared term, coefficient 15c. X squared term, coefficient 15, that's very nice, because that gives you exactly 1. Now what about the x term? X term, 15d minus, but I know what c is. C is 1. Let's put it there. And it should come to a minus 31. So taking that across, that will give you a 15, that makes it a minus 15. So that means you've got, I'll just put it down, 15d is minus 15, so d is negative 1. And then finally go to the constant term. So you've got 15e, but I know this, 8 lots of d, notice that minus 8, I'm just going to go straight in with this now, so that's actually plus 8, plus 2c, plus 2 should come to 40, well there's 10 away from 40 is 30. 15e equals 30, so e equals 2. Now you can finally put that back together. Not left myself enough room to get that and then add that onto it, so I'll just crush it up. So yp is going to be, putting it all together, it was order CDE, so 1 lot of x squared minus 1 log of x plus 2. Meaning the general solution is going to be, I'll just be able to fit it in here, made up of this part, the freebie, ae to the 5x plus be to the 3x, plus this particular integral for the general solution. Ooh, wibbly wobbly. But that's not the end of it, because now I have to employ these initial conditions to find what a and b are to get the particular solution. So, create some space. Then, I'm going to use these conditions now. So I can use the first one straight away. When x is 0, y is 4. So 4 is equal to a e to the 0, b e to the 0, and it looks daft, I'll just put in those ones as well, which will give me one connection between a and b, because that just says a plus b equals, take that 2 across, equals 2, right? Now I'll need to differentiate it, so I can use this second one. So that will be 5a e to the 5x, 3b e to the 3x, 2x, just minus 1 and gone. Now I can call in x equals 0, y dashed is 13. So 13 equals, here we go again, 5a e to the 0, 3b e to the 0, plus 0 minus 1. So what have I got? I've got 5a and 3b equals, take that one across, and that's a 14 for number 2. Now just solve that pair. I think I'll get rid of the b's. So if I do 2 take away 3 lots of 1, I'll have this. I'll have 5a take away 3 will be 2a, and of course they disappear, and I'll have 14 take away 6, which will be 8, which gives me a equals 4. And then I'll put that in number 1, because number 1 says 4 plus b equals 2, so b equals negative 2. Now I can put it all together. So y equals a 4e to the 5x, b minus 2e to the 3x, and then the other one just stood x squared minus x plus 2 for the final solution.